Today I am going to explain a subtopic of chapter Electrostatic, and the topic is charge on an electron by Millikan method. In this topic, I am going to explain the charge on the oil drop and the radius of the oil drop with the help of the experiment which is known as Millikan experiment. This experiment consists of a glass chamber in which there is a vacuum and two oppositely charged plates are placed in the glass chamber, and there is an atomizer which is used to spray the negatively charged oil drops. A microscope is used to see the suspended oil drops. When the atomizer is used to spray the oil drops, then some of the oil drops are suspended between the positively and negatively charged plate. One thing keep in your mind, the oil drops which are sprayed by an atomizer are negatively charged. For example, this oil drop is suspended between the positive and negatively charged plate. When this oil drop is suspended between the positive and negative charge plate, it means two forces are acting at this oil drop. The first force, which is equal to its weight, which is acting downward, while the second force is electrostatic force. Since the oil drop is negatively charged, so due to the electrostatic force which is acting in the upward direction, the oil drop is suspended. At this situation, the weight and the electrostatic force are equal. Now we can write it as Fe means electrostatic force, which is equal to Fg. Fg means weight. Okay. We know that Fe, electrostatic force, is equal to QE, charge multiplied by intensity. Okay, E is equal to F upon Q, and F is equal to Q multiplied by E, which is equal to weight. We know that weight is equal to mg. Now, electric field intensity is equal to V upon D, as we know that, as we have read in this potential gradient, in the topic potential gradient, that electric field intensity is equal to electric potential divided by distance between the plates. Okay. Now put the value of electric field intensity in the above equation. So the above equation will become Q multiply V by D, which is equal to mg. Now here Q is equal to, we will solve it further by cross multiplication. So Q is equal to, D will multiply with this mg, it will become mgd upon V. Okay. Now we have got the value of the charge of the oil drop. Okay. Here he has concluded that the charge on the oil drop is the multiple of the minimum charges, and this minimum charges is 1.6 into 10 power minus 19. He has got the value of the charge of the oil drop, and he has concluded the total charge of the oil drop is equal to the multiple value of this charge, minimum charge, which is 1.6 into 10 power minus 19, which is equal to the charge of electron. So he has concluded this. Now, if the electric field between the plates is switched off, then the oil drops moves down with the terminal velocity. Okay, if the electric field between the plates is switched off, and suppose the oil drops moves with the terminal velocity, because there is no electrostatic force at this moment, because the electric field is switched off. So the oil drop, and suppose the oil drops moves down with the terminal velocity, then at that situation, when the oil drops are moving, when there is no electric field, between the plate, there is no positive and negative charge, and the oil drops is moving with the terminal velocity, then the two forces are acting on this oil drop. The first force, which is equal to the drag force. You have read in the class 11 fluid dynamics, drag force, which is equal to 6 pi eta r Vt. Vt means terminal velocity. Now, at this situation, when there is no electric field, there is no positive and negative charge, then the oil drops will move with the terminal velocity, and the oil drops moves with the terminal velocity. Then two forces are acting on this oil drop. The first is drag force, which is acting in the upward direction, and the second is the weight. Now, at that situation, the drag force, which is, as you have read this drag force in the chapter fluid dynamics in class 11, drag force, which is equal to 6 pi eta r Vt. Eta means coefficient of viscosity, Vt means terminal velocity, r means radius of the molecule, which is equal to mg. Okay, this is equation number 1. Now, as we know that density of the oil drop is equal to mass of oil drop divided by volume of oil drop. Solve it further. Mass is equal to volume multiplied by density. If the oil drop is spherical, therefore volume of the oil drop will be V is equal to 4 upon 3 pi r cube. Put this value in this equation. So it will become M is equal to 4 upon 3 pi r cube and density. Now put the value of M in equation number 1. So equation number 1 will become M, put the value of M which is 4 upon 3 pi r cube density multiplied by G, this G, which is equal to 6 pi eta r Vt. Now cancel this value. Pi will be cancelled, this r will be cancelled, and this is r square. Okay, solve it further by cross multiplication. This 3 will multiply by 6, so it will become 18. 6 is 18 r square. Here r square is equal to 18 eta Vt upon 4 density and G. So solve it further. 2 2s are 4 and 2 9s are 18. It will become r square is equal to 9 eta Vt upon 2 rho G. Now with the help of this equation, we can find the radius of the oil drop. Okay. So with the help of this Millikan experiment, we can calculate the charge of the oil drop as well as the radius of the oil drop. Thank you very much. Allah.